ComStar, the domestic telecommunications satellite, takes its position in orbit, 22,300 miles above the equator, and is now ready to begin its job of relaying long-distance calls between points on opposite sides of the continent. It's the latest milestone in a constantly expanding technology that began when Alexander Graham Bell first displayed his invention in 1876 at the Centennial Exhibition in Philadelphia. The Earth Station represents a significant application of space-age technology. 7 Earth stations are integral parts of a joint effort of the Bell System and General Telephone and Electronics Satellite Corporation. Bell System stations are located at Woodbury, Georgia, near Atlanta, Three Peaks, California, near San Francisco, Hanover, Illinois, near Chicago, and Hawley, Pennsylvania, near New York. GTE stations are near Los Angeles, Tampa, and Honolulu. Each site is close to major metropolitan areas where many long-distance calls originate. Valleys like this offer natural protection from radio signals that would interfere with the signals from space. Against the sky, each antenna looks big. The dish itself is almost 100 feet in diameter. But the entire 400-ton assembly can be turned with precision. More than 150 tons can tilt up and down to achieve a precise alignment between the satellite and the Earth stations. The signal from space is received, and amplifiers, cooled by helium to 260 degrees below 0 centigrade, strengthen the signal. This specialized equipment converts the signal so it is now ready to be received by the terrestrial networks. Cable facilities, or a conventional microwave tower, links the station with the telecommunications network. And when you make a call that passes through this system, it's handled the same as any other call.
Grandma, you know my dog Tommy, he just had babies. You want one?
The system works, and it's designed and built to keep working.
I'm saying a puppy just for you.
Oh, well, that's nice, dear.
There will be 2 active satellites and a third one for backup in the event of an equipment failure, and for use when the path of the sun with its powerful radio noises crosses the path of the other satellites. There's a standby antenna at each Earth station, and another satellite can be launched from Cape Canaveral should the need arise. It's a thoroughly reliable system that actually had its beginnings here at Bell Labs, Crawford Hill, New Jersey. In 1960, signals were received here after bouncing off a huge reflecting balloon in space. Called Project Echo, it was the first time a long-distance call was launched through space. In 1962 and 1963, signals were received by this horn from our Telstar satellites. They were the first satellites to pick up a signal, amplify it, and transmit it back to Earth at a different frequency. Since those early days, satellite systems of many nations have taken their positions 22,300 miles above the equator. Experts suggest that by 1985, orbital crowding may become a problem. To solve this, Bell Labs is conducting an important experiment. Special high-frequency beacon transmitters are carried on the Comstar satellite. These devices beam experimental signals back to Earth. A special antenna has been built to help scientists perform tests on these signals, especially under adverse weather conditions. At higher frequencies, more communications channels can be used than on lower frequencies. But higher frequencies are affected by weather, and scientists at Bell Labs will try to determine to what extent communications may be impaired over extended periods of time. Antennas of today receive signals from only one satellite. The Bell Labs antenna has been designed to receive signals from more than one satellite. The experiment is expected to yield data essential to develop multi-satellite receiving and transmitting antennas for Earth stations. If successful, this could reduce crowding by making satellite systems more efficient and economical. As the nation's communications needs continue to grow, demands on the network become even more complex. We already have more than 140 million telephones, each capable of connecting to any other in the system. That's several billion possible connections. 470 million are actually made on an average day. In long-distance calling, part of the connection may be by microwave radio, part by coaxial cable. And if your call is to Europe or to any other point across the water, it may well go on a cable along the ocean floor or through the international satellite system. The network is something like a complex brain, making many decisions as the call proceeds, bypassing points where there are equipment problems, bypassing routes that are busy, to make the most direct available connection between your phone and the other one. Switching has come a long way since the days of Hello Central. Electromechanical switches have been in use for many years, and they can make all the connections for a transcontinental call in the few seconds it takes your call to go through. But even minute reductions in the time it takes to make the connection will result in greater efficiency for the system. A new all-electronic switching system handles up to 550,000 calls an hour, 4 times as many as the equipment it replaces. The new switcher, like the new satellite systems, adds to the capacity while remaining thoroughly compatible with the existing Bell and independent company equipment, a key criterion both for General Telephone and the Bell system. The Bell system is one integrated entity. Bell Labs does the research and development. Western Electric manufactures the equipment with a thorough knowledge of the system requirements. The associated companies install and maintain the equipment in their own service areas, and they provide the direct customer service contact. Long Lines ties the associated companies together, and AT&T coordinates the whole effort. This integrated system has developed and put into use one technological innovation after another. Bell system people are still looking toward the future, making fundamental scientific advances and seeking practical ways of making these advances serve the nation's telecommunications needs. Bell Labs is working on ways of using light to transmit telephone signals. Such a system, to be practical, will require finding ways of combining tiny lasers or light-emitting diodes, unique sources of light energy, and hair-thin fiber optics that can transmit information by light, like wires conducting electricity. Making it all work together and making it meet the standard tests of reliability and compatibility with the existing system. That's a big order, and it's in the experimental stage now. But big orders and experimental work have given us what we have today. Almost 1 million people in the Bell system are working, inventing, planning, designing, experimenting, and building to meet today's requirements and tomorrow's challenges. The object is to continue giving you the best telecommunications service that human inventiveness and plain hard work can provide.